Have you ever shared pizza with your friends? In what fraction did you share it? Did you make sure that your friend didn't pick the bigger piece? Well, we all have done this. But what is this fraction? Can you relate this real life experience with maths? A branch of mathematics that I can relate to about all this is rational numbers. Rational numbers are used in everyday life for the purposes of calculation of taxes, loans, interests, or even when we share pizza. So what are we waiting for? Let's decode this chapter. In mathematics, a rational number is a number that can be expressed as the quotient or fraction, that is p by q of two integers, a numerator p and a non-zero denominator q. Therefore, when you split the pizza into 6 pieces and pick 2 out of them, then you get 2 by 6 or 1/3 of the pizza. Now, in the given figure, we can see how rational numbers can be related to integers, whole numbers, and even natural numbers. So let's study about them as well to see how each one of these blend with one another. Whole numbers and natural numbers. Natural numbers are a set of numbers starting from 1 and counting up to infinity. The set of natural numbers is denoted as n, whereas whole numbers are a set of numbers starting from 0 and going up to infinity. So basically, they are natural numbers with 0 added to the set. The set of whole numbers is denoted by W. Integers. In simple terms, integers are whole numbers and their negatives. The set of integers is denoted as z or I. Now 0 doesn't have a negative, so that means from 1 to infinity we are going to do the negatives. Next comes rational numbers. A rational number is a number that can be represented as a fraction of two integers in the form of p by q, where q must be non-zero. The set of rational numbers is denoted as q. For example, minus 5 by 7 is a rational number where minus 5 and 7 are integers. Even 2 is a rational number since it can be written as 2 by 1 where both 2 and 1 are integers. So let's solve a question before moving further. Pick up the rational number from the following numbers, that is 6 by 7, minus 1 by 2, 0, 1 by 0 and 100 by 0. Now since the rational numbers are of the form what? A by B, where B shouldn't be equal to 0, only 6 by 7, minus half and 0 are going to be rational numbers because 0 can be written in what form? It can be written as 0 by 1. And obviously minus half is of the form a by b where b is not equal to 0. And similarly 6 by 7 is the form a by b where b, that is 7, is not equal to 0. But when I see 1 upon 0 or 100 upon 0, I can see that b is equal to 0. Therefore, these numbers are not rational numbers. So to answer this question, I would say that alright, 6 by 7, minus half and 0. These three numbers are rational numbers. Now let's move further and study the properties of rational numbers. So the first property which we need to study is the closure property of your rational numbers. So for two rational numbers, say a and b, the results of addition, subtraction and multiplication operations give a rational number. Now since the sum of two numbers ends up being a rational number, we can say that the closure property applies to rational numbers in the case of addition. Now for example, 2 by 3 plus 3 by 4 is going to be what? It's going to be 8 plus 9 by 12, correct, when I'll take the LCM of these two. So the answer is going to be what? It's going to be 17 by 12. Now obviously 2 by 3 and 3 by 4 is a rational number because it's of the form p by q, or you can say a by b form, where q or b, or I must say the denominator of this fraction, is not equal to 0. Similarly, 12 by 17 is also a rational number because it's of the form p by q, or I can say a by b, where obviously q and b, here what is 12, the denominator is not equal to 0. So it's also a rational number where 17 and 12 are what? Integers. Now, the difference between the two rational numbers results in a rational number too. Therefore, the closure properties apply for the rational numbers in case of subtraction as well. For example, as you can see, 5, here is 5 in the denominator and 4 in the numerator, right? So 4 by 5 minus 3 by 4 is going to be what? 1 by 20. So it's going to be a rational number because 1 and 2 are what? Integers, and obviously 20 is not equal to 0. And in case of multiplication, what we are going to say? We are going to say that in case of multiplication of any two rational numbers, the result is also going to be a rational number. Therefore, we can say that the closure property also applies for the rational number in case of multiplication as well. A very good example is on your screen, that is half into minus 4 by 5 is nothing but minus 4 by 10, that is minus 2 by 5. And this obviously is a rational number because minus 2 and 5 are what? These are integers, and obviously 5 is not equal to 0. So we can say that the closure properties apply for rational number in case of multiplication as well. But when I talk about division of two rational numbers, we can see that for a rational number a, when a is divided by 0, then this whole thing is just not defined. Hence, we can say that the closure property does not apply for rational numbers in case of division. That is, I can say that 0 upon a is defined, but obviously a by 0 is not defined. Therefore, closure property doesn't apply for rational numbers in case of what? Division. But for addition, subtraction and multiplication, it's very well applicable. Let's move to the next property, that is the commutative property. Now, for any two rational numbers, that is a and b, when a has any relation with b, then this relation can be written as that b has a relation with a. Which is to say, you can see on the screen that if a is related to b, then b has to be related to a. But we need to define what this relation is. Whether it's addition or subtraction or division or multiplication, what is it? So let's find it out. So the commutative property is 1, wherein the result of one equation must remain the same despite what? The change in the order of the operands. Given two rational numbers, suppose a and b, so a plus b is always going to be equal to b plus a. Therefore, addition is commutative for rational numbers, right? And if I take an example, I can very well say that alright, 2 by 3 plus 4 by 3 can be written as 4 by 3 plus 2 by 3, which will always give me an answer what? 6 by 7. So we can see the same pattern in what? In multiplication of rational numbers as well. For example, 2 by 3 into 4 by 3 is going to be 8 by 9, whereas 4 by 3 into 2 by 3 is also going to be 8 by 9. So I can say what? That addition and multiplication, both of them are commutative. Alright. So before moving further, let's solve this question which is displayed on the screen. Now here it's given that we need to write two rational numbers whose multiplicative inverse is same as they are. Now, what is going to be the reciprocal of 1? Reciprocal of 1 is going to be 1, correct? And what is going to be the reciprocal of negative of 1? The reciprocal of negative of 1 is going to be negative of 1, right? Hence, the required rational numbers are what? 1 and minus 1. Here we can see that if I want to do reciprocal of 1, I can write 1 upon 1, and this is nothing but 1. And if I want to do reciprocal of negative of 1, I can simply write what? I can simply write 1 upon negative of 1. That is nothing but negative of 1. So 1 and negative of 1 is going to be the answer of this question. I hope you understood it. So let's move further. Now, the opposite case is going to be seen in what? The difference between the two rational numbers. Opposite in comparison to what? Multiplication and addition, which we just saw. So, considering the difference between two rational numbers, that is a and b, a minus b is not going to be same as b minus a. That is true. Therefore, subtraction is not commutative for rational numbers. And what's the example? Example can be that 2 by 3 minus 4 by 3 is nothing but minus 2 by 3. Whereas 4 by 3 minus 2 by 3 is going to be 2 by 3. So obviously, a minus b here is not equal to b minus a. And we can see similar results in division of rational numbers as well. Considering the division of two numbers, that is a and b, I can say that a divided by b is different from b divided by a. Therefore, division is not commutative for rational numbers. And there is this very easy example which is given on your screen to make you understand it clearly. Like, 2 divided by 3 is going to be 2 by 3, whereas 3 divided by 2 is going to be 3 by 2. And clearly 2 by 3 is not equal to 3 by 2. Therefore, division is not commutative for rational numbers. So let's move further. Here we have a question to solve. And the question says that if the value of A is given and if the value of B is given, we need to verify these two things. That is, A multiplied by B is equals to B multiplied by A. So A is half and B is what? 3 by 4. Whereas B is 3 by 4 and A is what? A is half. So it's going to be what? 3 upon 4 2s are 8. Here it's going to be 3 upon 8. So clearly left hand side is equal to right hand side. So it's verified. Whereas if I do A plus B equals to B plus A. So it's going to be half plus 3 by 4 plus 3 by, equal to 3 by 4 plus half. Here I can simply write 8, 4, 6 and here also 8, 6 plus 4. That is 10 upon 8. And here also I can write it as 10 upon 8 and I can finally write it as 5 by 4 equals to 5 by 4 from this. So left hand side equals to right hand side and hence it's verified. So now let's move further and understand the next property, that is the associative property. Now for any three rational numbers, that is A, B and C, when A, B are related initially and then the relation is done with C, this is going to be equal to what? When B and C has a relation first and then this relation is shared with A. That is, associative property is one where the result of an equation must remain the same despite a change in order of operands. Now, can anyone tell what is the difference between associative and commutative properties? They seem quite alike, aren't they? The associative property of addition states that you can group the quantities in different ways without changing the outcome. Whereas the commutative property of addition states that you can reorder the quantities without changing the outcome. Let's move further. So given three rational numbers A, B and C, it can be said that A plus B first and then with C is going to be equal to B plus C first and then with A. Therefore, I could say that addition is what? Associative. Now, a similar pattern can be seen in case of multiplication as well. As you can see here, that A multiplied by B first and then with C is equal to B multiplied by C first and then the product with A. That is, what I can say is, the order in which the numbers are multiplied doesn't matter. The product will always be the same. Therefore, multiplication is what? Associative. Now just tell me one thing. Are these two numbers equal? That is A minus B and then the answer is actually like C is subtracted from the answer which I get from this. And B minus C first and then the answer is subtracted from A. So the two numbers which I'm going to get, are they equal? They aren't, because A minus B minus C is nothing but A minus B minus C when I open the bracket. But A minus bracket B minus C is going to be what? A minus B plus C. And obviously, A minus B minus C is not equal to A minus B plus C. Therefore, we can say what? That subtraction is not associative. Now, a similar pattern can be seen in the case of division. That is, A divided by B and then the answer divided by C is not equal to A divided by B first and then divided by C. Actually, here what it should be this. So, it's a mistake. What it should be simply that A divided by B first and then divided by C is not equal to A divided by what? B divided by C's answer. So this should be what it is. This is wrong. So, but what I mean to say is that if these two are not equal, but what I meant is that if these two are not equal, then that means that the order in which the numbers are divided actually matters in case of division. Therefore, division is not associative. Now the last property which we are going to talk about today is the distributive property. So given three rational numbers A, B and C, then according to the distributive property of multiplication actually, it basically says that multiplication is divided over addition and subtraction. And how is it distributed on top of that? It's that suppose A is multiplied by A by B. So if A is multiplied by B plus C actually, then what I could say is I can say that AB plus AC is what I'll get. Whereas if A is multiplied by B minus C, then I can obviously like distribute this multiplication over the bracket. And how can I do that? I can write AB minus AC. So AB minus AC will be in case of this and AB plus AC will be the case of the first one. I hope you understood this. So let's move forward. Now we are going to solve a question to check. Now we are going to solve a question to check whether you understood or not. So the question says, check the distributive property of the three rational numbers, that is 4 by 7, minus 2 by 3 and half. So let's find the value of what? Let me find the value of 4 by 7 into minus 2 by 3 minus half, and I would say 4 by 7 into minus 2 by 3 minus 4 by 7 into half. So I want to actually calculate them. Okay. So what's going to be the answer is that 4 by 7 into this, when I'm going to solve it, can be like 4 by 7 into minus 4 minus 3 upon 6. So this is going to be nothing but 4 into minus 7 upon 7 into 6. So 7 and 7 is cancelled. So it's minus 4 by 6 and it's nothing but minus 2 by 3. So this is nothing but this is minus 2 by 3. Similarly here I can do what is, I can just solve this as minus 8 by I guess 21 upon minus 4 by nothing but 14. And when I'm going to solve this, it's going to be minus 8 by minus 6 upon 21. So this is going to be nothing but minus 14 upon 21. And this is going to be what? Minus 2 by 3. So you can say that this is equal to this. Alright, this shows what? This shows that left hand side is equal to right hand side. And this shows that this number and this number, both of them are what? Equal. So let's move further. And this is the next question which we need to solve. So what does this question say? This question says that what properties does the following expression shows? So we do not have to solve them. We just have to tell what properties do they explain. Now, in the first case, they are saying that 2 by 3 plus 4 by 5 is equal to nothing but 4 by 5 plus 2 by 3. So this shows what? The commutative property of addition of rational numbers, right? I hope you remember what the commutative property is, and if you forgot what that is, please go back in the video and check it out. The second one is 1 by 3 into 2 by 3 is equal to 2 by 3 into 1 by 3. So what's it going to be? Obviously this is also the commutative property, but it's of multiplication. So both these are the examples of commutative property, but one is of addition and the other one is of multiplication. Now, let's quickly do a recap of what all we learned and then we can just wrap up with it. Okay, so initially we started with introduction, then we studied the uses of rational number, then we studied what are whole numbers and natural numbers, integers and also the rational numbers. And finally we studied about the properties of rational numbers. And properties we studied about associative property, distributive property, commutative property and closure property as well. So we have reached the end of our discussion. Hope you found that helpful. Now you can visit EduRev to attempt the respective tests so as to check your understanding on the topic. You can also find more amazing content on other subjects like SST and science and whatnot. So what are you waiting for? Go and check it out. Also, stay tuned for more amazing videos. Thank you.